Is it recording?
Yeah. Come on, man. You dropped the pencil.
All right. Once again, you guys go to this. We did empirical formulas yesterday, where we just simplified. And this is attached to your lab. This is the back page that was attached to your lab. It says empirical formulas. Okay? Yes. Turn to the back page of your lab. That's it. All we did was simplify. So if you simplify, if they give you a formula like this, all you have to do is divide and simplify. Okay? But what if they don't? What if they give you a percentage like this problem? This says, determine the empirical formula of a compound that contains 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. This is tougher. Here's how you do it. I want you to set up a little chart like this. I want you to put Na for sodium, S for sulfur, O for oxygen. Alright? We are going to make a little chart out of this. Here is our chart. Or table, depending on how you define it. Like this. Alright, did you make a chart? Yes. First thing you're going to do is, I'm going to zoom in real close so we can see this a little better. I'm going to zoom in super tight. First thing we're going to do is take these percentages and we're going to change them into grams. 36.5% sodium, I want you to write that as 36.5 grams. 25.4% sulfur, I want you to write that as 25.4 grams. And then 38.1% oxygen, I want you to write that as 38.1 grams. We all see that? It's okay? It's alright? Raise your hand if you can't see it. Alright. Okay, write that down. Good. Next step. And this will be hard at first, but this actually isn't. The next step, you're going to go to your periodic table. I want you to tell me the mass of sodium. What's the mass of sodium? 23. We're going to divide this by 23 grams from the periodic table. Next is the mass of sulfur. What's the mass of sulfur? 32. And then what's the mass of oxygen? 16. What a smart people. Okay, if you can't see it, raise your hand. I'll tell you what it is. Anybody? Good. First divide this top one here. What do you get?
1.58.
You get 1.58. Okay, that equals 1.58. Sorry. Next, divide this one. What do you get? Do you get 0.79? Okay, 0.79. And then the bottom one, what do you get?
2.39.
You get 2.39 or 2.38 or 2.39 or 2.38 or 2.4? How about 2.4? Okay, so we've got those. Now, we're about to make our formula. We're about to discover what our formula is. Okay? But we have decimals. We're going to get rid of these decimals. We're going to do that by dividing by the smallest number. 0.79 is the smallest decimal. It's the smallest number on here. What's 0.79 divided by 0.79? 1. What's 1.58 divided by 0.79? 2. What's 2.4 divided by 0.79? 3. So you have an Na2, S1, O3. Your formula is Na2, SO3, sodium sulfite.
Oh, that's pretty cool.
All right, go to problem 3. We'll skip over 2. Go to 3. Go to problem 3. You have percentages here again. We do this the same way. Okay? Let me fix this. Sorry. Very sorry. All right. You do this the same way. Change your percentages into grams. You got 58.8 grams because you had 58.8%. You had 13.75%, 13.75 grams. 27.45%, 27.45 grams. Where do we get these numbers from? These ones on the bottoms.
Periodic table.
Get them from the periodic table. So the mass of barium is 137. See that? Right? Who does not see it? Raise your hand. Everybody comprende? All right. The mass of sulfur is 32 grams. Okay? And the mass of oxygen is 16 grams. If you have a question, you can ask me a question. I just won't use your name to protect your anonymity. Yes, ma'am.
Is that a 3 or an 8 next to a 5?
Right here, this is an 8. 58.8. Anybody else have a question? You can ask a question. I won't say your name. Okay, so this was 0.43, and this was 0.43, and this was 1.7. Why did we divide all these by 0.43?
Smallest.
It's the smallest decimal. So we got rid of all the decimals, and we got a 1 for barium, a 1 for sulfur, and a 4 for oxygen. So now we have Ba1, S1O4. Barium sulfate is our formula. Barium sulfate. Sir.
Back hurting.
Bless you.
Very bad.
Stop.
Okay. The next section. This is real quick. We're going to go over this lightning speed, okay? And don't worry, we'll do more practice later. Go to this one that says molecular formula.
What's the name of these formulas we just did?
Those are empirical formulas. Empirical formulas. All right, molecular formulas. This is one where you already have an empirical formula, okay? It says an organic compound has an empirical formula of CH3 and a molecular mass of 30. What's the molecular formula? The molecular formula means the real one. Well, there's a problem here. Okay? It says CH3 and then it says 78. What's the mass of CH3? Well, a carbon is 12 and you have 3 hydrogens, that's 3. That'd be 15 grams. 15 grams per mole and 30 grams per mole don't match. How much bigger is it? How many times bigger is it?
2 times.
It's 2 times the size. See, because 30 grams divided by 15 grams is 2. Okay? 2 times CH3 gives you a formula, a real formula of C2H6. And then the same thing here. Okay? An organic compound has an empirical formula of CH, that's 13, and a molar mass of 78. What's the molecular formula? This is 13. And how did I get 13? Where did I get this from? The periodic table. Carbon's 12, hydrogen's 1, that's 13. Okay, so you have 78. 78 divided by 13 is 6. This is 6 times bigger. 6 times CH is C6H6. Yes, question? The last problem right here, why did I not simplify it? Great question. Because empirical formulas are already simplified. They're the simplified version. If I want molecular formulas, I go back. I go back to the one I had before I simplified it. So that's what we're doing. See? This one is the simplified version. Multiply it times 6, you go back to the one you had before. Okay?
So weird.
All right? Press stop, Shell.
Oh, you said my name, man.
You're famous.